Working with exponents and logarithms. What is an exponent? Let's consider the example 2 cubed or 2 to the power of 3. Number 2 is called a base. 3 is called an exponent. The exponent of a number says how many times to use the number in a multiplication. In this example, 2 to the power of 3 is equal to 2 multiplied by 2 multiplied by 2, which is equal to 8. 2 is used 3 times in a multiplication to get 8. What is a logarithm? A logarithm is the opposite of a power. In other words, if we take a logarithm of a number, we undo an exponentiation. A logarithm goes the other way. It asks the question, what exponent produces this? So in the example, 2 raised to what power gives us 8? And can be answered like this. Please see the screen. Let's take the base number b and raise it to a power p, like 2 to the third power, and have it equal a number n. We get an exponential equation b raised to the power p equals n. In our example, that'd be 2 raised to the third power equals 8. The exponent p is said to be the logarithm of the number n. Most of the time this would be written log base b of a number, in this case n, equals p the power. This is starting to sound a bit confusing with all the variables, so let's show this with an example. 2 to the third power equals 8. Applying the exponent and logarithm rules, we get log to the base of 2 of 8 is equal to 3. So we have considered exponents and logarithms. The exponential equation b raised to the power p is equal to n. The logarithmic form is log b of n is equal to p. You can see the relationship. Let's just look at this for a bit. Let's look at a different example. What is log base 10 of 100? This can also be written in an exponential equation form. That is, 10 squared or 10 raised to the power of 2 is equal to 100. So, an exponent of 2 is needed to make 10 into 100 and can be written like this. Here we have another example. What is log base 3 of 81? In an exponential form, this is 3 raised to the power of 4 is equal to 81. So, an exponent of 4 is needed to make 3 into 81, and we can say log to the base of 3 of 81 is equal to 4. Sometimes a logarithm is written without a base, like this, log 100. This usually means that the base is really 10. It is called a common logarithm. Engineers love to use it. On a calculator, it is the log button. It is how many times we need to use 10 in a multiplication to get our desired number. Example, log 1000, which means log to the base of 10 of 1000 is equal to 3. Another base that's often used is E, Euler's number, which is about 2.718. This is called a natural logarithm. On a calculator, it is the LN button. It is how many times we need to use E in a multiplication to get our desired number. Example, natural log of 7.389, that is, log to the base of e of 7.389 is about 2. Negative logarithms. Negative. But so far we've talked about logarithms dealing with multiplying. What is the opposite of multiplying? Dividing. A negative logarithm means how many times to divide by the number. Example: what is log to the base of 5 of 0.008? Well, 1 divided by 5 divided by 5 divided by 5 is 5 to the power of minus 3, so it can be written as log to the base of 5 of 0.008 is equal to minus 3. Let's look at solving and simplifying some more examples. Log to the base 4, bracket open, 2 multiplied by x plus 7, bracket close, is equal to 1. In this example, we will look at how we can simplify the logarithmic expression by applying exponent and logarithm rules and relationships. You may recall this from earlier in the video. This short clip highlights the exponent and logarithms relationships. Let's apply this to the example. The exponential form of the log function is 4 raised to the power of 1 equals bracket open 2 multiplied by x plus 7 bracket closed. Let's make 2x or 2 multiplied by x the subject by rearranging the equation. This gives us 2x is equal to 4 subtract 7, which is minus 3 or negative 3. We can now rearrange again and make x the subject, and we get x is equal to negative 3 divided by 2.